let's get started. I'm Isaku Yamahata. I'm a software engineer at Intel. My background is Linux kernel and hypervisor. So far, I have been working on those areas. And recently, I'm working on SGX and also Graphene Library OS. In this session was originally planned as a joint session with Xiaoning Li from Alibaba Cloud, but unfortunately, he couldn't come. So I will give this presentation alone. In this session, I'd like to introduce what is trusted execution environment and how SGX helps it, and how to adapt it to run your Go language binary without any modification. Okay, now these days, cloud environment is quite widely adopted, and its security model is to trust your cloud service provider. Cloud service provider set up OS kernel or hypervisor so that any user can run any application in the same physical hardware, and so user can do anything. So cloud service provider has to protect themselves. In this case, OS kernel or hypervisor, so that users can do bad thing. However, Linux kernel or hypervisor is a huge complex software, so there are vulnerabilities. It's inevitable. So once kernel is compromised, whole system is vulnerable. So your data is in danger. So at worst, maybe there can be a malicious cloud administrator. So he can have a control of kernel or hypervisor. So in this case, he can simply inject, he can simply compromise the kernel or hypervisor without any vulnerabilities. Recently, good security practices, defense in depth. So we should have multiple protection, so that if one of the protections is broken, even in such case, your system can stay in safe. But in this case, we have only one protection. So the notion of trusted execution environment comes in. Basically, we have what is called enclave, and that is a sort of protected area. So even if kernel or hypervisor, or sometimes even firmware is compromised, your enclave can still protect it. For example, probably kernel or firmware can't read any memory in enclave. So that's the concept of trusted execution environment. So SGX software Guard Extension is one of the implementation of TEE, and SGX enclave is trusted, and SGX enclave is a special encrypted memory region within users. Special encrypted memory region in user space, and its memory is encrypted. So in DRAM or memory bus, the data is encrypted. So if you look into memory or DRAM or memory bus, you can read junk. And also, its execution starts with a measurement. So we can guarantee that its enclave starts with known state. So no one can modify its starting state. So we know its state is a known state. And also to help enclave to keep in safe state, its environment is restricted. For example, some instruction is not allowed. For example, read TSC or system call instruction is not allowed. If such instruction is issued, it results in undefined exception. So exception. So SGX is very good. So how can I adapt it? So basically, the answer is modify your application at the source code level. So we have to identify which data we'd like to protect and split your source code into trusted mode, trusted code, and also protect untrusted code. So we need to put source code to manipulate your data into enclave, SGX enclave. So this means major reorganization of your application, and also you have to run SGX, how to use SGX, and you have to use SGX correctly, and this is a very hard work. So to mitigate that cost, SGX SDK library is provided. So we can use library. So that and hard work of using using SGX correctly is done by its library. But still, we have to modify our application at source code level. So its adaptation cost is still high. So we want yet another option at low cost. So do you remember that Greg GKH said at his keynote, no one uses SGX. So that's the reason why I'm working on this. So I'd like to really provide a low cost option. So what means low cost to users? It means you can bring your unmodified binary. So then you can simply run your binary within enclave. So your data will be protected. So the problem is how? So one of the solutions is to use library OS. I said SGX enclave is restricted. So for example, system call cannot be used because we don't trust kernel. So we have to do something. And library OS basically provides a sort of Linux system called emulation. And so that unmodified application can be run inside SGX enclave. But there is a trade-off. If we use library OS, it will be a big software because we need to emulate Linux system code. So trusted computing base size will be large, but its cost is low. On the other hand, if we use SGX natively, its TCB size will be potentially very small, but its cost is high. So this is a very trade-off. So which choice is better for you depends on your requirement. So maybe, we have a restriction on budget. We have a restriction on engineering resource. Probably we have a pressure on schedule. So we need to choose based on those parameters. And probably this is not exclusivity. Probably if we have to do something urgent, we can use this low cost of this solution so that we can do something today. But later, we can run SGX more later, and if necessary, you can switch to another option. So this is a very trade-off, and it depends on your requirement. And right now, this option is missing, so I'd like to provide this option. So basically, how library OS supports unmodified binary inside SGX enclave. This is just a generic discussion. Basically, it's basically library OS targets C or C++ application. And usually it uses libc as a shared library. So shared library, libc as a shared library can be replaced easily. So typically library OS provides a modified libc, so that, which replaces syscall instruction with function call into library OS. So when application requests a system call, actually it goes into library OS, and then Linux system call emulation will happen inside library OS. And if it really needs a host system call, for example, file system I/O or network I/O, we have to use host kernel. So in that case, we exit enclave and it passes the request to untrusted code. And then untrusted code proxies system call into host kernel, which is untrusted. And in this case, in this security model, we don't trust kernel because kernel can be compromised. So it can return wrong, something bad result to try to do something with enclave. So trusted library OS has to check it returned result. It can be used safely to shield application itself. So I said main target is C or C++ library, but actually its applicable range is much wider because, for example, CPython is written in C, so we can run Python with library OS in enclave. So we can run Python inside the enclave. And how about Java? Actually, OpenJDK is written in C, so we can also run OpenJDK with library OS. So Java and Python and many other language is written in C. So we can apply this architecture to many languages. So the question is Go languages. It's no doubt Go language is one of the most popular language for cloud native application. And this is a citation from GitHub. It ranks number of pull requests, and Go language is ranked as 4. So we have to we'd like to really support Go language, and without Go language, we would lose many user base. But Go language is very unique, and it shows technical challenges to support for library OS. Actually, Go doesn't use libc, and it has its own runtime written in Go language, and its runtime is statically linked. So it's very hard to replace its system call with system call instruction with function call. And also, Go routing is a very unique feature for Go, and it has a very small stack size. And so if we simply function call into library, it is very likely to overflow its stack. So we have to do something. And also, because of its small stack size, it requires accurate emulation of POSIX signals. In fact, in C or C++ case, Unix signal emulation can be very inaccurate. Even wrong emulation, application can run, but Go doesn't like that. So it requires accurate emulation of POSIX signal. And also, its behavior is different from libc. So it has it push up pressure on system call emulation. So probably we have to fix many things. So so far, yeah, I have discussed generic things. So I'd like to move on to more concrete discussion, more concrete project. And actually, we picked Graphene Library OS project. This is an open source project, and in SGX community, this is well known and very popular one. And it is a library OS for unmodified applications, but Go is not supported. And it emulates Linux system call. And it supports multiprocess. This is very unlike a unikernel case. Unikernel typically doesn't support multiprocess. It means fork or exec can't be used. But usually, yeah, in CS application uses a multiprocess like Nginx or web server or database. Yeah, it is quite common to use multiprocess. So multiprocess support is very required. And also it supports multi-platform. Right now, as an open source, Linux is supported, and also FreeBSD is supported. And yeah, someone said they are working on Mac OS or Windows, but I don't know. But yeah, as an architecture, yeah, it can support any platform. And this slide shows its architecture. At the bottom of the layer, we have a platform adaptation layer to abstract its platform. And actually, its platform PAL is split into. One is the untrusted code to proxy system call request to host. And as in enclave, we have a platform abstraction layer. And on top of it, there is a library OS part, which emulates Linux system call. And on top of it, we have a modified glibc. And it converts, it forks system call instruction into function system call. So actually, when application requests system call, actually it will become a normal function call into library OS. And on top of it, we have a modified application. Typically, it's its own binary, and it comes with shared libraries. So right now, yeah, we are working hard to support the Go language. And right now, the current state is we are working on 2 upstream, but locally we have a sort of working code. And especially, yeah, we have a system called emulation. Even if application issues system call instruction, yeah, we trap and emulate it. And also, it's very slow because it incurs a sort of enclave exit or enter. So it's very catastrophic to its performance. So we have a further optimization. And also, yeah, we'd like to VDSO. We'd like to have VDSO. Yeah, because it's an optimization. And also, we introduce a dedicated stack to run library OS code because Go stack is very small, so we don't want a stack overflow. And also, yeah, we implemented accurate emulation of POSIX signal, like SIGALT stack and so on and so on. And yeah, we hit many system call emulation issues, and we are fixing it. We have fixed many things, and we are still fixing many issues. Actually, yeah, library OS is one of the problems of library OS is its emulation. To implement system call emulation is hard work. It requires much engineering resource. So yeah, last part will continue. Okay, so let me show demo. So now we have a small, simple hello world example. And yeah, just it uses a Go routine and it prints hello world. And yeah, it's very simple to understand. And now next step is to measure its application so that we can have a measurement. And then when we run this application under SGX enclave, yeah, we can guarantee it's not modified by someone. Now we will start measurement. Right now we create a memory image of the enclave and measure it, and its measurement is this value. And then next we try to run this Go binary under Graphene Library OS. And it starts, and it takes a while to measure memory, and because measure memory, and then output is printed out, and this is only shows its result. So next, I'd like to show how it behaves. So I enabled the debug option to show many debug log. So yeah, at first measurement is done, and measurement is correct, and then it starts many things, and it does many things because reaching to main function, there are many things to be done to initialize Go runtime, and and then actually many things need to be done, and then it exits normally, and actually it took many long time to reach main function. Okay. As a summary, trusted TEE is a key concept for cloud environment in secure way, and SGX is a basic building blocks for a TEE, and its adaptation barrier is very high, so we'd like to provide a lower cost option, and Library OS is one of the solution for it, and we are working on Graphene-SGX to support it, and the community is right now working hard to stabilize it, and we are planning to release 1.0 in July. So please give it a try. Right now, its quality is very stabilizing. And also, if you are a developer, please contribute to it, because this is a library OS, and it's sort of funny beast. So if you contribute it, it is sure you will fit many interesting bugs or issues. So you will get fun. Okay, that's it. So we have several times, so I can get questions. Yes, please.
My question is that Graphene-SGX for Golang, if I want to run the Go application written in Golang, should I recompile the program with Graphene-SGX library, or using my unmodified binary with Graphene-SGX runtime?
No. I mean, unmodified means unmodified binary. You don't have to recompile or not. Just bring your binary.
Binary. Yeah, okay. So the next question is, you said Graphene-SGX is Go runtime, but typically Go binary is not have its own runtime, but it's the single binary. So how do you hook applications, a system call, or something by Graphene-SGX?
Okay, so your question is how to handle syscall instruction embedded in binary.
Yeah, it's very easy for GLC, but I guess it's very hard for Golang.
Requirement is we should not modify binary. So assumption is syscall instruction is embedded in target binary.
Yes.
So we have two approaches. Yeah. One is trap and emulate. Because syscall instruction is not allowed in enclave, so it triggers a UD exception. So we can trap it and emulate it. But it incurs a enclave exit and enter, and its overhead is very, very high.
Yes.
So we are implementing binary patching to replace syscall instruction with function call.
Binary patching.
Yeah.
Yeah. Yeah. Thank you very much. It's cool. Yeah. Thank you.
Hello. I have a question about the performance. So compared to the Go native application performance, so what's the? Did you measure the performance between in enclave and the native?
I see. Actually, it depends on workload. If it's a CPU intensive, it's almost the same because just the CPU runs inside the enclave, and it doesn't require any special work. But if your workload is system call intensive, probably you get worse performance. Actually, there is a academic paper on graphene, and it shows some results on normal binary case, not Go language case, but I guess tendency would be similar.
Okay, thank you.
Hi. I had a question about the Iago attacks. So
sorry?
Iago attacks. Yeah. So my group we did a similar exploration with library operating system. So this was like based off the Scone paper. And we were looking at the Iago attacks, and then we were trying to figure out how do you do shielding, right? The Scone paper mentions shielding, but they don't really say how to do it.
Yeah, that's right. Yeah.
So what we ended up going into was like we went into this whole hypothesis that in order to perform proper shielding, you would have to replicate kind of all the data structures in the host operating system anyway. So,
yeah, actually, to shield Iago attack is difficult, and at least, Graphene has a file system protection. We can have a hash value for file system files, and we can specify it. And then, we read files, and then we calculate hash, and then we check if hash is same or not. Yeah, because it's slow. Yeah, but it's a trade-off security and performance.
Yeah, I think like the one canonical example was the malloc example, right? Memory allocation, like how do you like, and also like with because using Graphene, you're supporting multiprocess. Then when I do a fork, how do I know it's not giving me back like a PID, which is weird.
I see. So so to protect against Iago attack, actually. Library OS minimize the use of host system call and try to emulate it as much as possible inside library OS. For example, MR case, library OS tracks which virtual address space is used, and then just MARC is or mmap is handled inside library OS. So in that case, host kernel is not used. So to minimize attack surface from kernel, Graphene minimize the use of host system call.
Yeah, so what we were trying to do is to minimize the host system calls, we tried to use the Solo 5 interface.
Yeah.
Yeah, but yeah, this is cool. Thanks so much.
Yep.
Can you provide SGX protection at a container level instead of individual binaries?
Container level? In theory, yes. And yeah, in theory, yes. And Graphene Library OS itself, yeah, it allows. Because it supports multi-process and fork and exec. And right now, we don't have a container runtime yet.
Because that would probably solve the need to handle every single programming language and how it interacts with syscalls. Another question. I'm not very familiar with how SGX works internally. You mentioned that it encrypts the memory. Mm-hmm. Where do the encryption keys live?
Inside the CPU. Yeah, inside the CPU. And actually, yeah, for memory encryption, on enclave boot up, CPU creates its key internally, and then it uses it, and software cannot know it.
How does it map to the specific trusted process? How does it prevent a different process on the same host from using the key?
So there is actually, yeah, we can create multiple enclave, and enclave is key is associated to the enclave. So if we have a different enclave, key is different. And actually, I'm not a hardware expert, and I'm not the right person to answer such implementation question. Okay. Thank you for coming.